How to become data analyst. You can boost your career in the data analytics field by joining our Data Analytics Certificate Training Program. In our Data Analytics course, you can gain complete knowledge of data analysis, data management, and mathematics for data analytics, and statistical programming for data analytics, and data modeling. There are a variety of tools available to learn about data analytics, such as Microsoft Excel, Python, and R programming, Advanced SQL, Power BI, and Tableau. So, to become a data analyst, you need to have a thorough knowledge of data analytics. And for this, you need to learn the following skills and tools. Data analysis. Data analytics is the process of examining data to find trends and draw conclusions about the information contained in the data. Data is a collection of facts and information. In the first step of data analysis, you should determine the needs of stakeholders and decision makers. Here are some questions to define the problems you want to solve, and determine what stakeholders and decision makers need. How do my stakeholders describe their problems? What can I do to assist the stakeholders in resolving their issues, once I have identified the issues? Data collection. A variety of methods are available for collecting data for decision making. For data collection, you may use past data from your database, or you can conduct an online or offline survey. You can use Power BI to get the data directly from the website, or you can also get the data from the server. You can import data from XML, or text files into Excel. Data cleaning. The process of data cleaning is to remove irrelevant and incorrect data from the data set, and to remove corrupted and incomplete data from the data set. We have following steps for data cleaning. I remove duplicates. 2. Remove irrelevant data. 3. Data formatting. 4. Convert data type. V. Fix errors. 6. Handle missing values. Data mining. Data mining is the process of finding hidden patterns in data, and extracting useful information from hidden patterns in raw data. By utilizing data mining tools and techniques, businesses can predict future trends, and make better business decisions. Data management. The primary purpose of data management for vast quantity of data is to ensure that reliable, up-to-date data is always available for decision-making during the requirement. An organization's data management involves collecting, storing, analyzing, and sharing data. Data management includes customer relationship management, data warehouses, and data architectures. For us, data management consists of the following steps. Data quality. The efficacy of data is measured by its quality. Data quality is a measurement of data completeness, accuracy, consistency, uniqueness, reliability, or data validity. Data quality refers to the suitability of data to be used for a particular purpose. Data security. Throughout the data life cycle, data security protects digital information from unauthorized access, corruption, or theft. Security practices ensure data integrity across applications and platforms by encrypting, hashing, tokenizing, and managing keys. There are 5 types of cybersecurity. 1. Critical infrastructure security. 2. Physical security. 3. Application security. 4. Network security. 5. Cloud security. 6. Internet of Things, IoT, security. Data warehousing. Enterprise data warehouses are also known as data warehouses. A data warehouse is a central repository where information is gathered from one or more data sources to make more informed decisions. The 3 main types of data warehouses are enterprise data warehouses, operational data stores, and data Martinique. Data warehouses are designed for querying and analyzing data instead of transaction processing. Typically, a data warehouse contains historical information derived from transactions. Data governance. A data governance process involves establishing internal data standards and policies to ensure data is available, usable, secure, and has integrity. Data governance refers to establishing internal standards, such as the data policies, that apply to how data is collected, stored, processed, and disposed of. It controls who has access to what types of data and what types of data are subject to management. Data sharing. Making data available to other people is known as data sharing. From educational institutions to corporate entities, different types of organizations share their data in a secure, legitimate, and secure manner that protects data integrity. Mathematics for data analytics. Mathematics is an integral part of data analytics. For data analytics, you need to have a strong background in specific mathematical fields, like linear algebra, calculus, statistics, and probability. Mathematics helps analyze large amounts of data to extract useful information and identify common patterns and trends to convert them into meaningful information. 1. Linear algebra. The study of linear algebra involves the study of lines, planes, vector spaces, and mappings required for linear transformations. An equation like this describes a two-dimensional line. Y equals 4x plus 1. There are following topics of linear algebra. 1. Multiplication and addition of matrices. 2. Determinant and inverse of a matrix. 3. Matrix-based systems of equations. 4. Vector spaces in Euclidean geometry. 5. The concept of eigenvalues and eigenvectors. 6. Matrix with orthogonal rows and columns. 7. Positive definition matrices. 8. Transformation in linear form. 2. Calculus. Calculus is commonly used in data analytics for classification, clustering, and regression. Calculus deals with numerical quantities like real number-valued quantities. Therefore, an understanding of the basic set R of all real numbers is essential. Real numbers are those that can be written as decimals, positives, negatives, zeros, terminating, or non-terminating. 3. Statistics. Statistics help us understand general trends and patterns in a given data set to make predictions about future events and behaviors. Statistics also helps answer questions that decision makers have about problems. There are following topics of statistics to learn. 1. Central tendency. 2. Variability. 3. Relationship between variables. 4. Probability distribution. 5. Hypothesis testing and statistical significance. 6. Regression. 4. Probability. Probability helps us decide the likelihood of something happening, such as weather forecasting, sports, and gaming strategies, buying or selling insurance, online shopping and online games, determining blood groups, and analyzing political strategies. In data analytics, we use probability to analyze random events. Data analytics life cycle. The data analytics life cycle is a circular process that defines the roadmap of how data is generated. In the circular process of data analytics, there are 6 basic stages that define how information is created, collected, and processed to meet corporate objectives. It provides a structured method of handling data so that you can find your answer to questions to achieve your objective. There are following steps of data analytics life cycle. 1. Discovery and formation of data. 2. Preparation of data. 3. Preparation of models. 4. Developing models. 5. Communication results. 6. Implementation. Statistical programming. For data analytics, you need to learn R programming or Python programming. But we recommend Python programming because it is easy to learn, and different types of libraries are there for data analytics, like n-dimensional, NumPy arrays, and pandas data frames. For statistical programming you can learn following programming languages and LibreIRs. 1. R programming. 2. Python programming. 3. N-dimensional. 4. NumPy arrays. 5. Pandas data frames. 6. Visual basic programming. Data modeling. By applying specific formal techniques, data modeling creates a data model for an information system. Data modeling is the process of displaying a software system and the data elements it contains using text and symbols. Data modeling can be categorized into 3 categories: physical, logical, and conceptual. 1. Data are stored in databases using physical models, which outline how they are stored physically. 2. Using a conceptual model, you can visualize your data at a high level and see it from the point of view of a user. 3. Data can be logically represented and decoupled from its physical storage through a logical data model, which sits between the physical and conceptual levels. Tools for data analytics. With the evolution of data analytics, the range of tools available for data analysis also grows. What data analysis tools do you need to learn if you plan to pursue a career in this field? Here is a list of data analytics tools. 1. Advanced Microsoft Excel. 2. Power BI and SQL. 3. Visual Basics for macro building. 4. Tableau. 5. SAS. Thank you so much for watching this video. Please like, share and subscribe my YouTube channel.